Okay, we've talked about the general form of a quadratic equation being ax squared plus bx plus c. Now we're going to look at what's called the standard form. So the standard form of a quadratic equation is one written in the order f of x is equal to a times x minus h squared plus k, where a cannot equal 0. The vertex of this parabola is the ordered pair hk, and the axis of symmetry is the vertical line x is equal to h. So it's really helpful if your parabolas are written in this form. You can just look at your equation and tell what your vertex is, which direction the graph is going to open based on A, and then also what the axis of symmetry is. So let's look at the example. It says, given the quadratic function f of x equals -2 times x minus 3 squared plus 8, determine whether the parabola opens up or down. I'm going to look at the leading coefficient, -2, because it's less than 0. That means that this parabola will open down. If the parabola opens down, that means that you have a maximum at that point. Okay, then B says find the vertex. So I can just look at the equation. The vertex is going to be hk, which this is h, this is k. So my vertex would be 3, 8. And notice I did not carry this sign over to the ordered pair. It's just the number h and then the entire sign of k. So hk would be 3, 8. Find the x-intercepts. Okay, the x-intercept is the point where that graph is going to cross the x-axis. So you would want to be able to solve for where your function is equal to 0. Okay, so if I take my equation, -2 times x minus 3 squared plus 8, and set it equal to 0. Now one way we can solve this is by using the square root property, which will probably be the easiest way. So I would want to get x minus 2 squared by itself. So I would have -2 times x minus 3 squared equals -8. Divide by -2, so that would give me x minus 3 squared equals 4. Then I can use the square root property here to take the square root of both sides. X minus 3 equals plus or minus the square root of 4 would be 2. Add 3, so that would give me x is equal to a positive 3 plus or minus 2. So we have two solutions, which is what usually would happen with a parabola because its degree is 2. One solution would be x is equal to 3 plus 2, which is 5. The other would be x is equal to 3 minus 2, which would be 1. So those two values would be your x-intercepts. And I know a lot of times on the homework, they just want you to type this as an integer. Okay, it is actually a point, and it would be the point 5, 0, and 1, 0 if we looked at it as an ordered pair. You'll just have to read your directions to determine if they want you to type it as an ordered pair or just as an integer. Okay, to find the y-intercept, the point where the graph is going to cross the y-axis, you would have to actually evaluate the function at 0. So you would want to find what is the function at 0. So if I take my equation and plug in a 0 in the place of x, we would get -2 times -3 squared plus 8. So -2 times 9 plus 8, and that would equal to -18 plus 8, which would be -10. So the graph will cross the y-axis at -10. Again, we know this is a point 0, -10. Okay, so then it says on part E, you're ready to graph the function. So I know my vertex, 3, 8, so I would plot that first. Okay, I have my x-intercepts at 5, 0, and 1, 0. So this would be 5, 0, this would be 1, 0. And I know that this graph should cross the y-axis at negative 10. So 0, negative 10 would be here. So this would be our graph of the parabola. And notice that it does open downward because my leading coefficient was in negative. Okay, part F says to find the axis of symmetry. Okay, the axis of symmetry is always going to pass through your vertex. And it's going to be the vertical line that just kind of divides that equally in half. Okay, so my axis of symmetry would be x equal to 3, because that's the x value of your vertex. Okay, then part G says to find the domain and the range of the function. Remember, domain is always associated with your x values. So if I look at my graph from left to right, this graph is going to continue to go down, but it's going to get wider as it goes down. Okay, so that means my x values could be any real number from negative infinity to positive infinity. Now the range is what will always be different, and you'll be asked for the range most of all. Okay, if it is a downward facing parabola, then I know I have a maximum at the vertex. So I look at the y value here, that's the maximum y value I can have for this graph. So I know it's going to go up to 8, and I put a bracket because it can include 8. Now what is my lowest y value? We said this is going to continue to go down, so that would be negative infinity. So my range would be from negative infinity up to 8, and that would include 8.